Hi, and welcome back to the FishBites Devlog. It's February 7th, 2022, and what I've just done in the application is made it to where once a fish has laid an egg, if another fish swims over it, I should say if another mature fish swims over it, that fish will fertilize the egg. So if the fish is too young, just hatched, less than 25% of its full size, it's considered immature, and it cannot lay an egg or fertilize an egg at that point. But once it's mature, 25% of its maximum size or more, a fish will swim over an egg and will fertilize it. What that means is the fish will pass on, the fish that swims over the egg will pass its genes into the egg. So now the egg has two sets of genes. It's got its own genes, which came from the fish that laid it. Now it's got a new set of genes also. And what you see on the screen there is the code when that happens, when that collision happens. And first I have to double check that it's not the fish that laid it, because that's what was happening at first. I forgot, oh yeah, when the fish lays an egg, it's going to immediately collide with it and think it's fertilizing it. So I had to check to be sure it's not so the egg actually knows what fish number laid it, so it can prevent that fish from fertilizing it also. So when a fish fertilizes it, you'll see the first thing it sets is this is in the egg. This is in the egg C# script. It's called egg.cs. So we'll call this method fertilize egg, and we'll pass to it the fish genes from the fish that fertilized the egg. Inside the egg, it sets a flag, is fertilized equal to true. That will prevent the egg from getting fertilized again. So it can only get fertilized one time. Then it's going to take the highlight color is the white spot in the middle of the egg. And once it gets fertilized by a fish, that white spot's going to change color and become the color of the fertilizing fish. So the eggs, you can look at an egg and tell if it's fertilized or not based on whether it's got a white center or a different colored center. So then you can look at the egg and get an idea, well, a pink fish laid it, but a blue fish fertilized it because it's blue on the outside, or it's blue on the inside and pink on the blue on the inside, pink on the outside. So you get a visual indication that an egg has been fertilized. And then the next thing it does is it says, okay, what are the genes going to be in the egg now? For the hue, the color of the fish genes, it actually is going to take the midpoint between the fish gene, the egg's current hue value, and the fertilizing fish's hue value. And it will take the midpoint of that using this method that I created. Won't bother showing you that, but if you want to ask about it in the comments, I'd be happy to show that to anyone who wants to know. So the color is going to be the halfway point between the two fish, which is a bit troubling because the halfway point between pink and green might be yellow or something. Just it doesn't make a whole lot of conceptual sense. So I might change that. And I'll talk about that here in a second, what I might change that to. But then for the rest of the genes that are being used in the fish currently, the max width of the fish, in other words, its full-grown size, the length ratio, how does the length compare to the width of a fish? Is it a long, skinny fish or a fat, short fish? And then the preferred speed that the fish wants to go. What's the preferred percent of the max velocity of the fish? Of course, the max velocity of the fish is based on the size and the length of the fish. So that's determined by the length ratio and the max width together. But then you have this percent preferred here. So how does that work? Well, for each one of those genes, it picks a random number between 0 and 1. And if the number is greater than half, it's going to change the eggs genes to the fertilizing fish's gene for that. So really it's saying 50-50 on any gene. It can come from either parent. So that's currently how it works. I did some print statements to check that out to be sure it was working properly, and it was. What I'm thinking about changing, though, is maybe instead of just having the color just be the midpoint of these two colors from both fish, that almost has a randomizing effect on the colors. It's not doesn't really communicate very much. I was thinking I might change the script slightly to where it's going to track which genes it's taking from which parent, and whichever parent has the most genes taken from it, use the color of that fish or make that color. Maybe the color will be shifted some toward the other color, but it's mostly the color of the fish that's giving the most genes. So that way the color has some representation of the genes connected to it from originally. So that's how that goes. So let's take a look at the app here, and we'll see some eggs getting fertilized. Okay, so here we are back in the simulation. Let's see if we can pull up the egg folder and zoom in on some eggs here to see if we can see. There's a normal egg, and it just spawned a fish. Okay, we're catching him too late here. Not fertilized fish. See the white dot in the middle? Oh, okay, that pink fish is born. Let's pick a fish that's an egg's gonna be around for a while. There's not many fish yet in the population, so they're not getting fertilized much. I do have a printout here. It's hard to see. Where I actually want to see how many eggs are getting fertilized versus how many eggs are not getting fertilized. So I've got this print here happening, which will show me right now about 10 to 15% of eggs are getting fertilized so far. So now we're up to 20% as the number of fish increase, number of eggs increase. I've also realized that I can increase the number of eggs that get fertilized by having the eggs take longer to hatch. If the eggs are sitting there longer, more chance of another fish swimming across it. So let me see if I can try to catch us an egg here that's getting fertilized. Oh, there's one. So there you can see a fish that's been fertilized. An orange fish laid it, and then a yellow fish went across it. So let's watch this this egg here and see what color comes out of it when it hatches here. See how long it takes here. It's coming up pretty soon. Should hatch next. There we go. Kind of a yellowish orange fish, kind of somewhere in between. And there he goes. So at least we are seeing the colors there, and when I've inspected the genes that get passed, they are indeed a mixture of the fish that are contributing genes to it, both the one that lays it and the one that this one's over by the wall, and the one that fertilizes it. So one thing I am trying to think about is, should I have any fish be able to fertilize any other fish egg? Or should I have it where a fish will only fertilize an egg if it's similar enough to its own color, for instance? To help the genes kind of group together and form species better. Oh, there's a blue fish that got fertilized by a red, and it turned into a green fish. So there's a good example of a blue and a red fish spawning a green fish. So that's what happens with the colors, I'm afraid. An orange egg, not fertilized, so it just came out orange. Oh. Okay, so what I've done here is I've opened up the global data manager, which is my global variables. I've changed the eggs hatch seconds from 2 to 10. So it's going to take 10 seconds before each egg hatches. And since my time scale is set here to 4, slowing down factor of 4, it's going to take 40 seconds for each egg to hatch, with the idea being I'm surely going to be able to catch some eggs getting fertilized if I can watch them for that long. So let's give that a try and see if that works. To make those kick in to be actually static variables, I need to go into my settings here and select apply changes, and that copies the global data to the static data. So let's take a look at an egg here, just laid by the purple fish. We should have plenty of time to watch it here. So let's hope we can see it be fertilized here. That one's already been fertilized. That one's by the wall. Oh, there we go. So you saw it turn from green, white to green and pink. Then the other yellow fish swam past it. Did not change the fertilized color there. So we'll see what kind of speed the time scale up a little bit here. See what kind of fish color comes out of a green and pinkish purple combination. Okay, we're getting close up, and it turned into a yellow fish. So you'll see it's not easy to predict what color is. So I might change that to where the color will actually be based on the what fish gave contributed the most genes to the fish, and just use that color. So looking at our ecosystem right here, we'll see orange fish really dominate. They're little, they have big mouths, they can take big bites of food. There's just tons of them. Like little minnows swimming around. I think full size is only about this size right here. So that's it for this log. Thanks for listening. Thanks for watching. The next steps are what? I might change it so the hue of the fish is the most, the fish that gives the most genetic material to the fish. And I need to start thinking about eye placement, eye vision, using colliders to track the vision of the fish and have them behave accordingly. Also need to have them swim towards an object, not swim randomly. That's probably what I need to do next, actually. I think about it. So that's what's going to come next. That's going to be a little bit challenging, but I'll post on here when we've got some progress in that area. So thanks again.